Hi, everyone. In this video, I want to quickly walk you through a use case and how to implement it with NiFi. This is a very common use case. There are many ways to do it with many different tools, but I've been asked to look at this use case with NiFi and how to implement it with NiFi. So I will do this in this video. So the use case is quite simple. You have messages landing into Kafka and you want to consume those messages. And then based on some conditions, you want to do some Kafka routing, basically send the messages into different Kafka topics. In this case, the messages that I'm receiving are JSON records. Two fields in those JSON records are application and event type. And I have a table in external database that is giving me a mapping where for each pair application event type, I have a topic in which I want to send this message. So I need to consume the messages from Kafka and route the messages in the desired topic based on this mapping table. This is fairly simple. And you can do that with NiFi very easily. I'm going to show you two ways for doing this. The two approaches are quite similar in terms of performances and capabilities. So it's really up to you to decide what you prefer, but it's just a way for me to show you two different options for implementing this use case. Okay, so let's get started. So here I have some processors just used to generate some data. So here I have a generate flow file that is just generating a bunch of records, JSON records, where I have my field application, my field event type, and that's it. And then next int for the ID of the JSON record. And I'm generating 100 flow files like that. Then I'm using a merge record processor with JSON reader, JSON writer, and just publish Kafka record into a Kafka topic that is NiFi source. I define parameters for this. So here, this is a parameter and the value is here, NiFi source. So this is just a data generator for my use case. Here, I use this to execute some SQL queries against the external database that I set up. So I started an RDS instance in AWS, and it's just a way for me to use NiFi as a way to execute SQL queries directly against this database. So I basically use this to create my mapping table, insert some values, and in the end, my mapping table is looking like this. So I have 3 columns: application, event type, and output. Output is the name of the topic in which I want to send the data based on what are the values for application and event type. So that's really it. The first option is, so the first thing to really think about is how frequently is your mapping table going to change? That's important because in NiFi, you have this lookup record processor that you can use to look into the records that you have in your flow file and enrich those records individually based on a lookup service. And this lookup service is basically in charge of getting the value associated to the key that you are giving. So in my case, the key for the lookup is going to be the pair, application, and event type. For the lookup service, you have many options. Let me stop this. And if I do here, create new service, you can see that we have a bunch of options for the lookup services. The two options I'm going to use today is the database record lookup service, where I'm going to directly check in the database the value I want. and also the CSV record lookup service, assuming that I have a CSV file local to my NiFi node where I have this mapping. So the first approach that I'm going to show you is with the CSV. So obviously, well, I want to have a way for the CSV to be available on all of the NiFi nodes and updated automatically when some changes are applied in my mapping table. So that's what my flow here is doing. I'm basically executing a SQL query to retrieve all of my items inside my applications table, which is my mapping table that I was talking about. I'm writing this as a CSV. So if I stop, let me stop all of this so that we can go step by step. Here, if I stop this and run once, so it's basically going into my database, retrieving everything. And I have a 3 nodes NiFi cluster, so it's generating 3 flow files, 1 per node. And if I look at the data, that's what I have. So that's really what I was showing: application event type output, and then the options I have here. The next step here is actually to do a small transformation on my CSV data, because if you remember what I said, the lookup service are only expecting 1 single key. That's actually an improvement we could do in NiFi to allow for multiple keys when we are doing a lookup, but right now we only support a single key, which means that I can't say, please look into this table and find me the column output for key A plus type 1. So the trick I'm doing here is to actually concatenate application and event type as a new column key and output. So this is really a query record processor, which is giving you the ability to run SQL query on your data. So if I start this, and now if I look here, I still have my 3 flow files, 1 per node, and here now I have the key column with the concatenation of A and type 1 and the output here. So that's what I want. Then here I'm updating the name of my flow file with the attribute file name, so that then I can use the put file processor where I'm putting this file into /tmp, and I'm saying if the file already exists, please replace it. And that's it. And here, the execute SQL record processor is configured to run every 1 minute. So every 1 minute, I'm querying my database, getting the output of the mapping table, and updating the CSV file on my NiFi nodes of my cluster. That's what this part of the flow is doing. It's a very simple one. And it's taking care of the aggregation of my application and event type columns so that I have a single key lookup. That's what it's doing. The reason why I'm doing this is because the CSV lookup record service is automatically checking if there is a new file. So whenever the lookup file that we use in the CSV lookup controller service is changed, we will check again to see if something changed in terms of what should be the value associated to my key. So that's why here I have this running every 1 minute, so that worst case scenario, if I'm making a change in my mapping table, it will be available on my NiFi nodes at most 1 minute later. So that's it. I will stop this here, generate some data here, refresh. So I have some data here. So I generated data in my source Kafka topic, and I can see this is coming here. So let's list the queue here and see what the data looks like. So here I have a bunch of records, and you can see application A, type 1, application A, type 2, etc., etc. So that's really the data I'm generating, nothing crazy here. The first step that I'm going to do here is to create a field that is the concatenation of the application and event type, because I need to generate the key that I'm going to use in my lookup records processor to retrieve the output value here, right? So here I'm using the update record, and I'm saying I'm going to create a new field called lookup at the root level of my JSON payload. And this is the concatenation of application and event type. So that's what it's going to do here. So if I start this and look after what it is, here I can see that I have a new field in my JSON, which is the concatenation of application and event type. And that's what I'm going to use as the key for my lookup service. So here in my lookup record, I'm saying that it's JSON for the input. I'm still writing JSON, and I'm using the CSV record lookup service. The CSV record lookup service is very simple. It's looking at this file that I'm writing in /tmp, and the lookup key column is named key. So that's really it, okay? And it's returning all of the other columns. So if I had more than 2 columns in my CSV file, I will be returning all of the columns except for the key ones. So that's it here. And if I go back here, so I'm saying that the key is the field lookup in my input. I'm saying that for the record update strategy, I use the property here. So basically, I'm saying where should I insert the value retrieved with my lookup service. So I'm saying, please add it at the root level of my JSON payload, insert the record fields that we retrieved. So basically, as I said, since the CSV is only containing another column named output, it will create a field output with the corresponding value. And then here I'm saying route to matched or unmatched, meaning that if some records cannot be matched into my mapping table, one flow file will be split into 2 child flow files. One flow file will go in the matched connection with all of the records that I was able to enrich with my lookup service, and one flow file with the records that didn't match to anything will go in the unmatched connection. So that's here. But in my case here, all of my records are matching something in my mapping table. So this is going to the next step here. And if I look here, I can see that now I have another field that is output with the value that I'm expecting based on my mapping table. Then, as we said, based on this value, I want to send the data into different topics. So I'm going to partition records, use the partition record processor and say, partition the flow files on the field output. So basically for one flow file going in, please create as many flow files as needed so that each flow file is containing records with the same value for the field output. And by the way, add a flow file attribute topic with the name of the output value that is common to all of my records in the flow file. So here, if I start this, basically I'm creating a bunch of flow files here. And if I look here, for example, this one, I will see here that all of my flow files are going to the same output here. So that's what the partitioning is doing. And in addition to that, in the flow file attributes, I have a new attribute here with the name of the destination topic. So now I can just connect this to the publish Kafka records and use the flow file attribute topic to say, please send this into the right topic. Just something important to note here is that I'm using the JSON writer with a specified schema, because the data that I want to send here in this topic, I want to remove the 2 fields I added. So that's where I'm specifying the schema that is expected. In this case, I'm specifying the schema text directly in my writer, but like in production scenarios, you will probably connect NiFi to a schema registry where you can better manage all of your schemas. By the way, this is just a usual comment, but as soon as you are using the readers and writers in NiFi, which is something I highly recommend you to do, you won't when you go to production, you want to have a schema registry and specify the schemas. By default, the readers and writers that are available in NiFi are using schema inference, which is great. This is cool. This is making your life much easier. But inferring schemas for all of your data first is impacting by a lot your overall performances. And it can cause issues because inference is always limited to whatever input you are providing. And maybe the input you have at some point in time is not containing all of the fields that you want, and the inferred schema will not be perfect. So really be careful about schema inference. That's great to make your life easier, but when you go to production, you really want to leverage a schema registry and have proper schemas defined for your use case. This is also a very good way to protect your downstream systems, to make sure that in case your sources are adding new fields or changing types of some fields and so on, you are protecting your downstream systems and avoid any like breakage in your downstream systems. So here I'm just sending the data and that's it. That's how it works. Now, you may be wondering why I'm not doing my lookup directly against the database. And that's a very good point. So the reason why I'm not doing this, well, I'm going to do it. The reason why I was not doing this initially is because of this, this key system. As I said, we have to provide a single column for the key. I can't provide two columns as the key for my lookup. Right now, this is not an option in NiFi. So actually, what I'm doing here is quite simple. Here, with my trick to execute SQL queries, I said, please create a view, add view, that is the select of the concatenation of application and event type as key, plus the output column from the applications table. So I just create a view on top of my table. And now in the lookup record here, I can use the database record lookup service, which is configured exactly the same way as the other one. And here in the configuration, I'm saying, okay, I'm connecting to my Postgres. I'm using the apps view table, which is a view, but like here, I'm just giving the name of my view. The key column is key. The value column that I want to retrieve is output. Here you could provide multiple columns if you want. And here I'm saying that I want to leverage caching. So I'm going to say that I have a cache of 1000 entries. When I'm enabling the controller service, I clearing the cache to make sure that when you are starting it, we always retrieve the latest data from the database and so on. So the caching is quite powerful because you don't want to always send queries against your database, especially if you are processing billions of events, right? But you always need to keep in mind if caching is the right option for you, depending on how frequently you are going to update this mapping table. If it's something that you are changing once in a while, then caching is perfectly fine. If there is something we can't, like if a key is not in the cache, we will query the remote table to see if the key is available and update the cache and so on and so on. But if you are, so you can also define the cache expiration because something that is important is that adding new mappings in your table is perfectly fine. And this is something that is managed perfectly well. But if you are, let's say for B type 3, you are changing from sync 4 to sync 2, for example, in that case, it means that you will have to wait for the cache expiration for the lookup to check again what's the new value here. So in the end, it's the same result as doing the CSV, except that for the CSV, we are checking every 1 minute because that's the frequency I set for the processor here. You could set the same duration on the cache expiration property, and you would get the same behavior. And that's it. That's really the same approach, but using the database record lookup service. That's working exactly the same way. Now, if I want to show you what kind of performances we can expect, so here I'm going to really generate as much data as I can, and I'm going to start this. So here now I'm going to generate a ton of data, and I'm actually going to do the two CSV and database lookups at the same time. And something that could be well, interesting here, but actually in this case, I'm not even sure I'm going to generate enough data to see some back pressure starting. So I can process a lot of data. Actually, let me, I can here. Let me stop this. And here, let me say 2 concurrent tasks here. And let's say that I want here apply, and here I'm going to generate more data here. Okay, so start. So I'm really trying to generate a lot of data, and we can see that the generator of data is actually where the bottleneck is, which is kind of expected. So I'm going to let this run for a bit, just to see how things are working. But you can see that right now with my setup, I'm not able to actually generate enough data in the input topic to actually create back pressure in the two. Remember, for every message that I'm generating, I'm doing the lookup twice, one with the CSV approach, once with the database approach, and I'm sending this into the destination topics. Now, actually, if I go here in SMM and I want to look here, we can see in the destination topics that I'm generating a lot of data. So we can see here that I'm generating, we are almost at 1 million messages here. I don't know how fast this is updating here. I think it's every 5 minutes or so. But we can see here that if I'm looking at something like this, we can see that I have my producers on NiFi, and that's generating a lot of data and so on. So here actually the CSV. Okay, so so that's interesting, but that's something as you can see, it's been retried automatically. I guess that we had a very unfortunate error where we tried to do a lookup while I was reloading the file here. So it's a very rare exception, but we just retried, and that's fine. It went in. So actually, just because of this, this is probably not going to happen frequently, but just because of this, maybe using the database approach is better. And obviously, you can imagine that the caching is an obligation, because otherwise we would be making a request to the database for every single record. And that's not an option, because here, if I look at status history here, we can see here the number of records processed. And well, this is increasing, but we are close to 12 millions on a window of 5 minutes. I'm still going to wait a bit so that we reach a plateau for the sliding 5 minutes window, sliding window, just to make sure we have like consistent performances. But you can see that's really, I'm generating a lot of data, but not enough to create any kind of issue. And I didn't do any kind of optimization here. So I could imagine some additional concurrent tasks. If we look here on my cluster and we look at system, we can see that my nodes are active, like they are processing data. There is a lot of data being processed, but remember, I'm doing the work twice, and I'm also doing the data generation. So all of this is also activity that my NiFi nodes are doing. But I think we are almost reaching a plateau here. I think it's been 5 minutes. So we can see now that we are at about 2 gig of data processed every 5 minutes. And remember, we are doing it twice. And those 2 gigs, if I look at records processed, and I look just for here, so we can see now that we are reaching a plateau here. But we can see that the max is almost 21 million messages on a window of 5 minutes. So you can easily process billions and billions and billions of events without any issue, and you can increase how many topics you should send data to. So that's it. I hope it was interesting. Or you can see that this error is actually happening a bit more frequently than expected. But again, this is happening probably because we are trying to update the lookup file here, and we are trying to do a lookup at the same time, and this is generating a built-in. But we are retrying the data immediately, and this is working. So everything is working as expected here, because we are rollbacking the flow file in the input relationship, and that's it. So yeah, well, this is a perfect demonstration on how you can use the database record lookup, and in this case, this is better. And we are using the caching so that we are not really sending millions or billions of requests against the database. That's it. That's the demo I wanted to show you. I will share the flow definition with you in the description of the video. Thanks for watching. If you have similar use cases you want me to walk you through and build some flows to show you how to tackle some specific use cases, feel free to drop a comment and I will look into it. Thanks again, and see you at the next video.